Okay. So today we're going to talk about surface area. So hopefully by the end of the class period, you're able to understand what surface area is and how to find it. We have here, it certainly isn't a perfect rectangular prism, but ideally that's what we would have. But we got what we call a rectangular prism here. This thing has faces, lateral faces. Okay? We have a front, a back, a top, a bottom, a left, a right. Okay? How many lateral faces does this have? 6. 1, 2, 3, 4, 5, 6. Okay? 6 lateral faces. Now, if we wanted to find the surface area, what it's asking us to do is find the area of each one of these faces and add them all together. Not too hard, because a rectangular prism is nothing but rectangles. All we got are length and width, right? And we'd be able to figure out the area of each one of these, because that's how you find the area of a rectangle, right? How do you find the area of a rectangle? Length times width. So let's just say that this length is 10, okay? And this width is 5. What is the area of this face? 50. 10 times 5, 50 for this area. Okay, then what's the area of the back? If it's a perfect rectangular prism, what's the area of the back? 50. Because we got this measurement here on the front should be the same as the measurement on the back, right? This measurement here should be the same as this measurement back here, right? So this should be 50, this should be 50. So if I were you, if I was doing this, I would make my thing front, back, top, bottom, right, left. Because your top and the bottom should be the same, your right and your left should be the same. So we've determined that the front and the back are both 50 square inches. 50 square inches. Now be careful. Some of you might feel that the top is also going to be 50. But is this measurement here, and I'm going to flip this prism for you, is this measurement here necessarily the same as this measurement here? No. I'm going to tell you right now, this one is 4. So if this is 4, what's the area of the top? Because this was what? The area would be 40. This was 10. This is 4. So my top and my bottom is 40. Okay. So we got 40 square inches, 40 square inches. And now we got a right and a left. Are they going to be the same? Yeah, they are. Because this was 5 and this was 4. That means that this is 5 and this is 4. Okay? 5, 4. 5, 4. So what's the area of each one of these sides? 20. 20. 20. And then if we wanted to find the entire surface area, all we do is add all these up. We got 20 and 20, which is 40, plus another 40 is 120, plus 100 is, so the whole thing is 220 square inches. That is the surface area of this whole thing. Pretty easy, right? So we got 6 lateral faces. Notice 1, 2, 3, 4, 5, 6. Find the area of each one and add them all up. Now we have a triangular prism. How many faces does this thing have? 5. 1, 2, 3, 4, 5. Now, when you look at a triangle, it's different than a rectangle, right? This length right here is not necessarily the same as this length here, is it? And it's not necessarily the same as this length here. So each one of these faces may be different areas. So you would have to say face 1 is whatever length times width is. Face 2 is whatever length times width is. Face 3 is whatever length times width is. And then you got your right and your left. Because the right and the left should be the same. Because these triangles should be the same. If it's a perfect triangular prism. And again, how do you find the area of a triangle? 1/2 times base times height. So 1/2 times this times whatever from here to here is. Okay? Now, and each one of these rectangles, you would take this side times this. And then for this one, you would take this side times this. And you would take, for this third one, you would take this side times this. Make sense? So we'd have 3 rectangles, 2 triangles, add them all together. You got it. Cool? Not too terribly difficult. Now comes the hard one. A cylinder. You know what a cylinder is? Let's pretend that this mug doesn't have a handle, okay? This would be a cylinder. Okay? Cylinder is a round. It's got 2 ends that are what? Well, the 2 ends are circles, right? But we got this part. Think about a can of beans or something. Can of green beans. Okay? You've got this area. We don't have any formulas for this area, do we? To find something that's round, do we? Question for you. How many of you recycle? Good, good, good. How many of you have to peel the labels off of the can of beans before you throw it in the recycling? Yeah, good. You should do that, by the way.
What about the bananas?
I'm not worried about that right now. Think about this. You peel the label off that can of beans. What shape is that label once it's peeled off of there? It's a rectangle, isn't it? Think about it. This is your tall can of beans, I guess. Okay? This is your tall can of beans. You got a circle on top, you got a circle on the bottom, right? But the outside is a rectangle, isn't it? It's not too difficult. If we wanted to find the area of this rectangle, what do we need? We need this right here, right? Which is really easy because that's just the height. That's just the height of the can. But this one's a little harder, isn't it? What do we know? Because isn't this right here? Isn't this the top side of that label? When I undo this, we have this length, don't we? Let me take that length and curl it back into that circle. What is this distance called? Circumference. So we have, if we can figure out the circumference or distance around this circle, we can figure out this length. This one's really easy because it's just the height of the can. This one's the circumference. This is the circumference of the can. So once we've figured the circumference of the can, which we'll just write down right here, and the height of that can, we can figure out the area of the whole outside of this cylinder, can't we? So let's do it. We're going to say top, bottom, and then we're going to call it, the rest of it is going to just be the, I don't know, the outside, or we could even call it the label if we want, right? Because it'd be like a label on the can of beans. So we'll call it label. So we got to find the area of each one of those things. Top and bottom, easy concept. Easy concept. All we need are two things. What two things do we need to find the area of a circle? What do we got to know? We really only got to know the radius, but we also got to know what we're going to use for pi. We got to know what we're going to use for pi. So I'm going to tell you right now that the radius of this circle, I'm going to call it radius of the circle, is 3 inches. I'm going to say that pi, we're just going to say pi, we're just going to round pi to 3 for now. And I'm also going to tell you that this can of beans, I'm going to say that this can of beans here is 8 inches high. It's a big can of beans. Okay. So we're going to say the height is 8 inches. We don't need height yet, do we? Because we're only finding this circle. We're only finding what the circle is. But we will need that. We will need this height in a little bit. So we have a problem here. What is the algebraic expression we need to find the area of this circle? What is the algebraic expression to find the area of a circle? It's in purple right behind me. Claire.
Area equals
Pi times the radius squared. Okay? So, yes, I did. Now you'll be happy because when you watch the video, it'll be on there for you. Okay? So, let's plug in the right numbers. A equals pi times the radius squared. What did we say pi was? 3. The radius? 3 squared. Solve this problem. 3 times 3 squared. First of all, Aunt Sally tells us to do the exponents first. A equals 3 times, what is 3 squared? 9. 3 times 3 is 9. What is 3 times 9? 27. So our top and bottom, they are both 27 square inches. So this is that. So far, we're doing pretty good. Not too bad. 27, 27. 27, 27. Now what we need to do is the label. We have to figure out the label. In order to find the label, we need to know what the height of the label is, and we need to know what the circumference of the circle is, because circumference is this length. The height we already know. I gave it to you. It's 8. How do we figure out circumference of this circle?
2 times pi times
we have the radius, so we're going to use this one. We're going to go 2 times pi times the radius. Simple enough. So we're going to go circumference equals 2 times pi times the radius. Circumference equals 2 times, what did we say was pi? 3. What's the radius? 3. What is 2 times 3 times 3? 18. So, our circle, or our label, I should say, I'm going to unfold our label for us, okay? Now, our label, we've determined now this is 18 because this was the circumference of the circle. So this is 18 here. So I'll write it right on there. 18. And what did we say? What did we say this was? We decided that this was 8. How do we find the area of this label? 18 times 8. I'm going to use my calculator. 18 times 8, 144. So our label is 144 square inches. Add all of those together, and it's going to give us our entire surface area of this cylinder. I'll check. 198. So this tall can of beans has a surface area of 198 square inches. Okay. I'm going to give you one practice problem. I'm going to give you one practice problem. I'm going to give you the dimensions of a cylinder. I'm going to say that the radius, I'm going to say is 5. I'm going to say pi, I'm going to say radius is 5 inches. I'm going to give you a pi of 3. And I'm going to give you a height of 4 inches. See what you can do with that. Find the entire surface area of that cylinder. We're just going to stop it.